Okay, so this is summary slides now. Okay, we started this whole story talking about NIO. We broke up the story into multiple parts. Okay, one was what is IO? We sort of saw that in another section. Then how is IO IPC? And we saw that IO is a producer-consumer problem involving IO devices and local threads. That's what IO is. Okay. IO-based IPC is the producer-consumer problem involving threads in different processes, right? That's IPC, inter-process communication. Okay. And we can do inter-process, and we want to be able to create independent buffers for different processes with which it communicates. So it's not like a pipe where the process is just communicating with one other process, preceding it, and one process maybe succeeding it. It's communicating with an arbitrary number of processes, which we want in general. Okay. And in a pipe, you can just go and attach two processes together which didn't even want to talk to each other, perhaps, which don't even know they're going to talk to each other. In this kind of communication, we want the client, if it is a client and a server that we're talking about, a client should decide which servers it's talking to, and a server should be able to decide which clients it talks to. Okay, so we have a most sophisticated set of operations than just pure I/O, which is what pipes are based on. Okay, we have a more complicated kind of I/O, but we would like to keep the awareness in processes as the awareness of communication as little as possible, given the constraints. So a client knows about a server, but the server doesn't know about specific clients, doesn't know which host they're on, which ports they're using, but the client knows something about the server, which host it's on, which port it's using. Okay, and a port number basically describes a service, a type of service. Okay, and you can have multiple instances of the service. Okay, depending on which process is using the service port, and you can accept on a listener port to create regular ports. Okay, so this is the stuff that we saw in great depth just now, so I won't go through this text here. I put this text here for studying, that, when you're studying later, you want to just get some succinct description of what. And reads and writes, the only interesting thing we saw here, they're just like reads and writes, except that they can get scattered and gathered. That was the only interesting thing from reads and writes. Okay. Then it became more interesting when we talked about blocking versus non-blocking. So all of these operations can block or not. And, this has been a big debate since I was your age. And people couldn't figure out whether they should block or not. And my generation thought, yeah, blocking is good because, we just create multiple threads. Threads are cheap. Till the web has exploded and you have servers with so many clients. That was not being imagined at that point. Okay. At that time, they were thinking we'll have a file server that talks to multiple clients on a machine. So we were talking about very few kind of clients. So when Java was created by Gosling, a little older generation than me, but that kind of generation, he was thinking we will have only synchronous operations. So non-blocking calls can return status values indicating if they executed or not. Okay, if you want non-blocking, but that is all polling at the software level also. So to prevent polling, it should be possible to wait for multiple operations to execute on multiple channels. One blocking call for multiple operations. Okay, that's still blocking, but it's a more flexible blocking. Okay, that's the NIO. Then we went into the NIO manager. Okay, which I really didn't want to because I had to do some more work. But when I gave students the ROX tutorial and they had to change it, all they had to do was change the interest ops and everything else was similar. And so it was the other code was just getting in the way. So I gave you an interface which let you do exactly what you needed to do, change the interest ops, and everything else remained constant. Okay, but then you didn't see the underneath code. So NIO manager gives you this high-level service, and you can parameterize service, and it has queues of command objects, okay, which specify application-specific functionality. And there's a notion of not just ordinary command objects, but command objects with initiate and execute, okay. And you can have your own command objects. Selecting thread is independent of, it just depends on the interface, not on the class. But there are some things that you expect to be done typically, and that stuff is put in the default command objects. but you still need some application-specific functionality. You need to know when a read occurs, for instance. So that's why we have listeners. Okay. So the predefined command objects make one set of decisions. There's multiple. Decisions can be made in multiple ways depending on your needs. Okay. And it's the principle that's been used there is to reduce copies and reduce thread switches at the expense of perhaps creating risky code. Okay. So you guys have to sort of manage the risks yourself.